So for my experiment, I analyzed the parabolic motion of a basketball throughout the course of a three-point shot. I compared velocities of the ball going into the hoop as well as at the same height during its upward motion. I tested how the height of an object in motion impacts the object's speed, not velocity, while experiencing constant acceleration, gravity. And so my independent variable was height, with my dependent variable being velocity or speed. So why basketball? Well, I've been around basketball since probably the time I was in middle school, and I've watched it and played it here and there. And from this time, I've learned that basketball has a huge community, not just in the US, but growing around the world. And so with this big community, I've been able to connect with many different people even more through knowledge of NBA or what happened in the Olympics and all that stuff. And so through this experience of mine, I've learned that the three-point shot is arguably the most popular shot in basketball today. Comparable to the dunk, but I'd say probably three-point shot is more popular. But people's shot forms can vary a lot. Um, and as well as the velocities throughout the shot and all that. And so I wanted to look into that a little bit because I found it kind of interesting. And so in my experiment, I recorded myself taking three shots from a three-point line, a real high school three-point line, around 6 meters from the basket with a hoop that's around 3 meters high. I completed it at an indoor basketball court, so that I don't have factors like wind or air density impacting results. And I determined the velocity of the ball at the same height but at different distances from the basket, one being when it's going into the basket and at same height in the ascending motion right after the shot release. And I record this, put this in the tracker, and analyze the Y position throughout the shot. And I also did calculations utilizing the kinetic energy equation and the potential energy equation. And so here's my system schema. The little cloud around it is supposed to be a dashed line and indicating that the whole thing is in the system, with the system including the hoop, basketball player, and earth, with contact and gravity being represented by C and G respectively, and how they correlate with each other. And so here are the pie charts, the one on the far left being at the point of release, because I indicated that being the reference height. And so since that's a reference height, that means the height there would be equal to 0. And so there'd be no potential energy. And so the only thing there would be kinetic energy. And as you go on the second energy pie chart, that's at the max height. So that's where um, potential energy is at its max. And so it takes up the whole energy pie chart. And so in that the third energy pie chart, it's about half and half because the height of the basketball going into the rim, which is what that one indicates, was around half of the max height, or right in between the max height and the point of release. And so the potential energy would be relatively equal to kinetic energy, with the total energy throughout the experiment not changing, indicated by the same size of the energy pie charts. So here's our first trial, the graph on the right indicating the Y position throughout the parabolic motion. And so I took the slope at the end where the ball went into the basket and compared it to the slope at the same height at around 1.6 shown here. And through that, I found the velocity of the ball or the speed. And I compared it to the equations that I did on the left when I put kinetic energy equal potential energy. And I found that the ascending speed and the descending speed were the same, but velocity is different because they're going up and down throughout the shot arc, respectively. Okay, same thing shown in trial 2 and trial 3. And so from compiling variables I found that could have been an experiment. When I shot the basketball, the basketball may have hit the rim on descent, which can impact the final velocity, or I may have stepped over the three-point line a little bit while shooting, or had different release points, whether farther away from me or closer to me from trial to trial, which both of them can distort the x distance of the ball's journey. But there are some external sources I found that go a little bit more in depth with the different ideas found in this experiment, dealing with velocity, distance, and how players' height and angle of their shot can impact the velocity of the ball needed to go into the basket. So in conclusion, I found that the displacement in the x direction does not impact the speed of an object at the same height during parabolic motion. And that absolute values of velocities, speeds on ascent and descent at rim height, the same height, were the same. And so height is directly proportional to the speed of an object in parabolic motion.